Good morning. My name is Alba. I'm a PhD student in an enterprise that is located here in Palencia. It's iuFOR-UVa. And today I'm going to talk to you about some of the things that I'm doing in my thesis, that it's about PGPR bacteria and their role in hazing black truffle production. One of the most valuable fungi is the black truffle, Tubermelanosporum. It is mainly distributed in the south and east of Europe, mainly in Spain, in France, and in Italy, being Spain the main producer of this fungi. It's mainly produced in plantations that are controlled with seedlings that have been previously inoculated in nurseries. The success of these plantations has led to its establishment in other countries outside its natural distribution, like Australia, the United States, or Chile, for example. Its benefits are really high, being higher than any other forest product in the Mediterranean area. But this is a plantation that has been established for so many years, but there is still many aspects that we don't know about it. These crops have a lot of fluctuations during the years, and some of the factors that can be related to these fluctuations are related to climatic conditions, the type of the soil, the agricultural management, or the organisms that are in the soil in these plantations. These are really difficult to control, and also the biology of the truffle is quite complex, and the interactions with the environment and with other organisms that are associated with it are still in research. But what we know is that there are some bacteria known as plant growth promoting rhizobacteria, the PGPR, that live in the rhizosphere, that is the soil that is next to the roots of the plants, and they can help to promote the plant growth. They can make it through different mechanisms like nitrogen fixation, pheromone production, pathogen-induced resistance, or improving the nutrient availability. So, knowing this, the objective of this study is to evaluate different bacterial cultures isolated from producing truffle plantations in order to identify those that have some PGPR activity and to study them in more detail. So, in order to do that, we made a sampling design inside the natural distribution of this fungi in Spain, in plantations that were already in production. Within 24 hours, we isolated the bacteria that were in the ground, and once they have grown, we separated them from each other depending on its morphology. And once we were sure that we have the bacteria strains correctly separated, we started to make the PGPR activities. The first of them is auxins. Auxins is a pheromone that works as a growth promoter. It helps essentially the root growth, and this is important for us because if the plant has a better root, it helps it to have more nutrient availability, and also because it helps the growth of the secondary roots that are the ones that the symbiosis with the black truffle is made. So if it has a better root, there are more points where the symbiosis can be made. Other PGPR activity is nitrogen fixation. Nitrogen is a really common element in the atmosphere, but in the form it is there, it's not available for the plants. So there are some bacteria that are able to convert the atmospheric nitrogen in forms that bacteria can use, like ammonia. Then the phosphate solubilization, there are some bacteria that are able to increase the availability of phosphorus in forms which the plants can absorb it. They make it producing organic acids that change the pH of the media and transform the and solubilize phosphate in soluble. And what we see in the lab is the change color of the media from blue to white. And the last PGPR activity that we are trying to test is siderophorus production. These are compounds that are able to bind the iron in the soil and make it more available to plants. Iron is not only a nutrient that is important for the plants, it also helps it to avoid the pathogens that are in the soil. So once these PGPR activities are tested, the next step that we are going to try is to make nursery trials testing the plant, the fungi, and the bacteria all together to know how they work and try to understand better how the soil microorganisms of these plantations can be used. And maybe in the future try to use it as a biofertilizers, avoiding the use of chemical compounds and enhancing the growth and the health of these plantations. And I would like to thank the founding and all the forest team and the people that is involved in this work. Thank you.